Hello, my name is David Hurd, and this is Lab 5 Choose Your Own Adventure. First, we begin with Newton's second law, the momentum principle, which states that a system's change in momentum is proportional to a net force, as well as the force of drag, which is a non-constant force that's equal to the proportionality constant times the current velocity squared. Now, we're going to be using two things. Position update formula and the velocity update formula, which goes as follows, and these initial conditions for the situation of a falling slinky. The purpose is to use the skills and resources that we have gained and used so far in a problem that we design. And we're supposed to show mastery of those prior topics. The bottom of the slinky in this example won't move until the top makes contact, and we'll discuss why in a moment. First, we start with the tracker model, which with the system being the slinky and the earth and the surroundings of the air. Here's some of the code for said problem. And here's the computational model. Now, this is what you look at when you have the combined model. And what's going on is that in the video, the top of the slinky begins falling and the bottom does not. However, if you track the center of the center of mass of the slinky, you will notice that it falls at a constant rate, or it falls as you would predict. Now, because of the spring force acting on both sides of the slinky, on the bottom there's a spring force up, and on the top there's a spring force down. Now, due to gravity, there's an additional downward force, which means that the bottom of the slinky has a net force of 0, and the top has a greater net force. So, the center of mass is not affected by the spring constant and the spring force, so it's moving by a constant force, while the two ends are moving at their respective different rates. Some possible error includes human error in terms of the tracking and dropping of the slinky, as well as incorrect approximations and unaccounted forces. Now, what does it mean? The center of mass, as I said before, moves as you would predict, but the spring force and drag force in the spring move the two ends together, and the bottom end ends up with no net force on it. Therefore, it does not move.